Good morning, good afternoon, or good evening, and welcome to another one of our JavaScript webinars. In today's session, we'll be focusing on the actual tooling side, so the actual developer environment to do your development. So what's the agenda for today? So today's agenda will be on first looking at what is Visual Studio Code. Then going into the different aspects that go into writing your code, whether it's the actual pure editing side, so writing your code, and then we'll look at how to how to deal with version control. We'll be looking at how Visual Studio Code will be supporting your version control systems and repositories. Then we'll look a bit at the extensibility side of the story. So how can we extend the Visual Studio Code default experience with your own other custom settings, but also how can we add extensions and plugins to the environment. And then we'll go a bit deeper into, especially when it comes to web development, you're all used to running tasks, whether it's gulp or grunt. And again, we'll see how we can fit that into Visual Studio Code. And then finally, we'll look at the debugging side of the story. Of course, when you're writing code, there's some debugging that needs to happen. All of your code may not be flawless, and through debugging, we'll see how we can easily detect where your bugs are in your code, all using Visual Studio Code. So as usual, feel free to reach out to us on Twitter, so by using the AskMSDev hashtag, and we'll try to get you an answer as quickly as possible. So send us your questions during this webinar, but also afterwards. If you're looking at the recording, just reach out to us, and we'll get back to you. So let's start with Visual Studio Code. Let's first look at why do we have Visual Studio Code there. So if you look at the spectrum of development environments, so on the left hand side, on one end of the spectrum, you have the code editors. Just as Emacs or VI. Or for those that want to use it, Notepad or Notepad++, and so on. On the other hand of the spectrum, you have the integrated development environments, so the big beasts of development experiences. So looking at an editor, well, the advantages of editors, or the kind of the key assets that you have with an editor is that it's really lightweight. So it's a small and lightweight experience, so you can get and write your code very fast. There's not a lot of distractions, and typically you work on a file or folder basis, so there is no such notion as projects, and pretty much you have extensions and support for different types of languages, development languages. Now, looking at the integrated development environments, such as Visual Studio Code or Eclipse or Xcode, depending on what type of development you're doing, those are more elaborate and environments which are really rich that provide you a lot of code understanding. So that you have IntelliSense, you have a debugging experience, properly built, and version control are all integrated in that same environment. So you get like wizard experiences for creating new projects. So they provide you a lot of value, a very rich environment, a very rich experience. However, they come at a cost, because they're quite large to download, and they have quite of a learning curve to get over before you can really get productive. Now, where do we position Visual Studio Code? It's really somewhere at the center, or maybe left of center here, because we want to still give you a lightweight experience, like the speed of writing your code of an editor, but still add some of those nice features that you have in an integrated environment. All of that in this lightweight experience. So support for multi-language, still have a notion of a project without it being a big and cumbersome concept. Of course, code understanding. So being able to quickly look at your code and see what is happening, go to find references, have a debugging experience, have a task running experience, all integrated in this lightweight experience, is what we want to position Visual Studio Code. So the richness of an IDE, but still as lightweight as an editor. Nice thing here to know is Visual Studio Code is a cross-platform development tool, so you can use it on Mac or Linux or Windows, and that's all due to us using the Electron shell, which basically Visual Studio Code was written in JavaScript and HTML, and that allows us to run it cross-platform. So you can download the installers for the different platforms. And nice to know as well is that it's open source. So if you have any feature requests, or you want to modify or look at the code of Visual Studio Code, just go to GitHub at the Microsoft VS Code repo and just look at the latest sources, the latest builds of the tool. Now let's get started. So how do you get started with and where do you get it? Visual Studio Code. Just go to code.visualstudio.com, and there's an install link. And basically the install. So we talked about lightweight. If you look at here, it's less than 50 megabyte download to download Visual Studio Code, which is quite small, especially if you compare it to the IDEs like Eclipse or Visual Studio, the full Visual Studio, which come at hundreds or even a gigabyte of download to get all of the features in there. And then you can basically add it to your command shell. So for pretty much for Linux and Windows, that happens straight out after the installer. If you run it on Mac, there will be inside of Visual Studio Code, there's a command just to install it to the shell, so that if you want to start it, as you can see at the bottom here, you can just type code, give it the name of a file, or give it a folder name, and it will open up that specific file or folder. Now looking at the kind of the basics of the code editing experience. So what does Visual Studio Code look like? And we'll dive in a lot of demos here. This is just a quick intro. So what it looks like is you could see here there's different components in the editor. So on the leftmost hand side you have kind of what we call the the view bar, where you have the different aspects. So you can look at your file. So the Explorer view will have a search view, we'll have source control view, and we'll have a debugging view. Now this is all sitting here in this left hand side, and then we have basically an Explorer bar. We can look at the different files and get your details, and then basically here you have your editing pane, and you can have multiple files side by side open. You can go up to three files side by side, and that will allow you to kind of either compare files and look at the different files at the same time. So enough talk now. Let's switch to a quick demo. So just to show you here where to get visualstudio.com. So just go to code.visualstudio.com, and then there's a download for Windows. If you click on the available on other platforms link, you'll basically get the links to the different downloads for the different platforms. So OS X, and then you'll have it for the different Linux distros. You'll have the download link as well. Okay. So once we have done that, we can go to a command prompt. And here I'm in a folder where I've just created a Node.js Express app. So there's a bunch of files here. And so how do you get started with code? You can just type code and then give it the current directory, and it will open up code. So it starts up very quickly. So we have that fast experience for writing code. Something to note here is that Visual Studio Code keeps track of your last session. So it will open up the windows and files that were open the last time you had Visual Studio Code open. So it restores that same session. So that gets you going really fast. So as mentioned here, so we have the different views here. So we have the editing pane, we have the Explorer bar, we have the different views here. So this is just the Explorer view. You can switch to the search view as well to search for specific words and items across the different files here in our directory. We can go to the version control view and also the debugging view. So we'll be diving into the different details of each of them throughout this session. Now, one thing you see here is Visual Studio Code. It's really keyboard centric. So developers very often are used to just using your keyboard and have keyboard shortcuts for every single thing they have. And basically that goes with Visual Studio Code as well. So you have a whole set of keyboard bindings available to you. You can do pretty much everything using your keyboard. And if you look at here, the different menu items here, so there's a number of menu items, so the standard menu items, but these are kind of basic. So there's a lot of functionality which is basically kind of hidden or available through what we call the command palette. So if you just press F1, there we go. Basically what you see here is this what we call the command palette, where you'll have access to every single command that is available inside of Visual Studio Code. So let's say we want to change the color theme of Visual Studio Code. We can just start typing, let's say theme, and we'll see preferences color theme. Just press enter, and then we can choose which theme we want to use. So let's say we want to switch to the light theme. There we go, and that's done through the command palette. Other specific settings that are available through the command palette are, for example, if we want to do some git operations, just type git, and we can look at the different git operations that are available inside of Visual Studio Code. Other things that we could set is we can customize a number of our settings. So if you type settings, you can either open our user settings or open our workspace settings. So let's say you want to open our user settings. There we go. So what we have here on the left hand side are the default settings that apply to Visual Studio Code in general, and then we can override them at a user level. So for you in your user account, have your own specific user settings, such as, for example, the zoom level. So let's say we want to change the zoom level to 2. That will change basically our zoom level across our environment. Some of these settings may be overwritten in a workspace setting. One of the settings you'll have here as well is, for example, the autosave. So you can save files automatically, and note that you'll have IntelliSense here. So if we do Control Space, you'll see that we can have the values after delay off, or we can have whenever the focus of a file changes, it will be saving automatically your file. So I prefer to have after delay, so that after when there's a short moment of inactivity, code will automatically save your files. Okay. So in here you can see the side-by-side editing as well. So there we go. So the command palette, just F1 is really your friend to go there. And find all of the commands that will help you operate basically Visual Studio Code. One thing to mention here, I talked about keyboard bindings. So if you type, for example, here keyboard shortcuts, press enter. Here you'll see all of the default keyboard shortcuts that are available to you. Well, you can basically override each and every single one of them. So you could start typing them, and let's say we want to have a specific keyboard setting overwritten, well, we can just copy this and paste it in here. Yeah, or we can just specify the key binding immediately by using the Control K keyboard shortcut. Okay, so everything can pretty much be customized here in Visual Studio Code. So let's close these as we go. Okay. One thing you'll notice here, so this is the editing pane. Let's say have a JavaScript file here. Is that we can do side-by-side editing. So I can open the, if I do Control click or double click, it will open up the file. If I do Control click, it will open it side by side. And as I mentioned, you can have 3 of them open side by side. What if you're working on multiple files at the same time? So one of the notions we have within Visual Studio Code is the concept of working files. And these are kind of the files you are currently or actively working on, where you have made some modifications. And basically they will appear here so you can get quickly access to them. So if you need to switch to the app.js file, very quickly you'll have them open in your working files. And this is kind of your most recently modified files, as to speak. And so you can remove files there as well. If you don't need them anymore, you can just remove them from your working files set. Okay, so this is a quick access to specific files. Okay. So that's a very brief tour across the environment. We'll see more as we go through more demos. Now there's the basic code editing experience, but what Visual Studio Code adds. So in the basic experience, you get some code coloring, and you get well, support for multiple languages. So we do a more advanced code editing experience. So one of which is, like for example, smart editing. For a number of the languages, we will be supporting what we call smart editing, which is allowing you to just select a symbol in your code file, and let's say and go to the specific definition. So, for example, a function or where a variable has been defined, you can go to the definition of that item, or you can find all references of that file, or just rename a given symbol, and it will replace every single occurrence of that specific symbol across your code base. IntelliSense will help you along the way, give you parameter information, will give you help information about specific functions, and so on and so on. So let's take a quick look at what that looks like in Visual Studio Code. Okay, so what we see here is, and just for the sake of readability, I'll switch to the a darker theme, which is the Monoke theme, where you can see you have a better view of the code coloring that is happening here. So we'll have the keywords which are marked in a color. We'll have specific strings also marked, operators get a red color here, and the specific note that you can change the color themes as well. So these can be customized as you go. So here you could see that we do recognize and we do code coloring. Also we do bracket matching and all those kind of things. Now, what is IntelliSense? For that, what I'm going to do is I'm just going to add a new file. Just clicking this one here, and let's call it utils.js. So just use some utility functions. Let's say some mathematical functions. So let's first define the constant for pi, and let's give it the value 3.14. And then we're going to, and we'll export a given function. Let's call it area, to calculate the area of our circle. It gets a radius as an input parameter, and then we'll return radius times radius, so radius square times pi. Already here you could see we get some IntelliSense. So pi is a constant number. You also get information about other functions or interfaces that are available to you inside of JavaScript. So you get basic JavaScript IntelliSense. If we now start using this specific function, let's say we create a variable v, which is the area. What you'll see here is area. You get the information about the function. It takes a parameter called radius of type any, and it's returning a number. So we do type inference as well. So because pi is a number and we're multiplying that with specific parameters, the end result will also be a number. Okay, so you get that information straight out of the box. So you can say area, and then again we'll get the parameter information here, and let's give it, for example, radius 2, and like this we get the information and we get some IntelliSense. If we take this a little bit further, so let's remove this one here, so I have our utilities JavaScript file created. If we go to the app.js here, so let's say we have all the way at the top here, let's say we will require our utils. So we're importing basically all of the exported functions and variables. What we can do now, we could say var v, just to show you that IntelliSense goes across different files as well. So we can do utils dot, and again we get our area function information here. Radius, we can put 2, and something like this. So we get the IntelliSense. You get IntelliSense for other things as well. So if you have, because v is now a number, if you do v dot, you'll see that we get methods here, like for example the toString, or we get the value and we get toPrecision. So we get numerical functions. If we take, let's say, a string, something like this. If we then dot, we'll get all of the functions that apply to string values. So here we get the character add, or we get a concatenation, we can get the length of a string, and you see that we get some additional information as well. So the character add a given position. So all of this you get inside of Visual Studio Code, so these IntelliSense. So I talked about smart editing. So what is, so we can right click here on the area function, and we could say, for example, peak definition. What this will do, it will get the definition and put it in line in our coding experience here. So without having to navigate to that specific file, we can have a look at the definition of that specific function here. So let's say we want to modify this, we could do this as well. So let's say pi is not 3.14, but it's 3.14, 15, something like this. So we can inline change it here, and it applies in that utils.js file immediately. Okay, so let's say we don't want a peak, we can also go to definition or use just the F12 keyboard shortcut, and it will navigate straight in here. Yeah. One of the things in addition we could do is we can find all references, and here you could see it's being used in app.js, it's being used here apparently twice, and it's also being defined here on utils.js. So this allows you to quickly search for given functions inside of your code base, or given basically operator variables as well. So you can go here, find all references of pi, which is here the definition, and then it's being used in this function here. Okay, just escape this one out. So this is kind of a light introduction how to do the IntelliSense. You might wonder, is there a way to get IntelliSense for existing frameworks? So let's switch to app.js. We can just remove this here. So here, for example, we're using Express. So you may wonder, so apparently I've already added this one here in a previous test. And Express basically does not resolve all of the type information. We don't get the IntelliSense for this specific. So you get IntelliSense for all of the operators, for all of the items you define in this given file. That you get automatically. If, for example, here you're using external libraries, what you need to do is you need to add type definition information. So how do you do this? We can just use what we call the typings tool. So you can do typings, install, and let's say we want to install something like this. We want to install nodes, we want to install also Express, and we install it globally. So you can just get the typings command line just by doing an npm install typings. This allows you to get type definitions what happens is, as a result of running this, you can see that there's a typings folder which was created, which gives us type definitions for Express and Node. These are basically TypeScript definitions, declaration files, which define basically all of the types for pretty much every single JavaScript framework. So if you want it for Angular, you want it for jQuery, well, you can do so. You can just add it by using the typings command line. So now we should be able to do Express. We may have to, one thing I need to mention here, for it to take that into account, we need to configure our kind of what we call a project. So if we're typing JavaScript, we can just add a JSConfig file, which will allow us to specify what target version of JavaScript do we want, what module system do we want to use, and all of this is defined as a JSConfig file. So it's just it should be a JSON file. Apologies here. So it's just a JSON file, and we can then add compiler options, such as, for example, and we get IntelliSense again here. So let's say we want to use the module system CommonJS as opposed to, for example, AMD. And what is our target JavaScript version? Let's say we target ES6, because we want to use all of the class systems, all the goodness that comes with ES6, like this. Okay. So now we have basically what we call a JavaScript project. Everything will be now marked as being ES6 compliant, and we should now be able to do Express dot, and you'll see that we get information now. We get IntelliSense for Express. Let's say, for example, here the apply method takes an argument here of type any. We get some information about that function, so you get full IntelliSense for that external library. So we can do bind, we can do call, and so you get all of the information linked to that specific framework. And the same thing goes here with, for example, directory name. It's a variable type string, and we could, for example, do a peak definition now. It will go and look it up in the specific case in the typings file. You'll know that it's been declared as a string variable. Yeah, we would be able to look at the different references as well. Yeah, so the smart editing again applies here also for external libraries. Okay. So in terms of IntelliSense, so you can see it here for JavaScript. Note that we have the same thing for, let's say, for example, for a package.json file. So for NPM packages, let's say we have a developer dependency, and we want to add, let's say, another dependency. We can just control space, and you get a number of JavaScript libraries here. So we're checking the NPM repository, the public one, to retrieve basically all of the available NPM packages. So let's say we want to use, we want to do some code coverage. So we want to use, let's say, Istanbul. Okay, so you can get here Istanbul. The latest version is 0.4.3. So let's take this one. So by default, it's using just any version. If you just don't specify it, it will come up with the currently latest version of the package. So we can just select, let's say, 0.4.3. We should probably remove this comma here. So we get IntelliSense for package.json for JavaScript files, but just as well we get it also for like bower.json files. Again, here you could add, you can add your packages, your dependencies for Bower. So all of that help comes just for free. And which is also maybe nice for web developers is if you have markdown files, we can also do your a preview of your markdown. So we have IntelliSense for markdown. So all of this you have available. But in addition, you can basically preview just by clicking this one or do Shift Control V, and you'll see basically your markdown preview here inline inside of your coding experience, which is also again very efficient in terms of not having to switch between tools while you're writing your markdown or doing other stuff. Okay, so this is kind of the basic IntelliSense and smart editing experience that you have. So we have it for a lot of things. Note that you can install extensions as well. So if you want, we don't have support IntelliSense for every single language, but basically we have a full set of extensions. We have a full marketplace of extensions available to you to add IntelliSense for other languages or for other frameworks. So just and we'll look at how you get these extensions later in this session. Okay. Switching back to our presentation here. Now we can write our code, so we have a lightweight experience. So an editor with some help through IntelliSense and smart editing functionalities that help you in writing your code faster. But how do you do version control? So Visual Studio Code has built-in support for Git repositories. So you can basically connect it with any Git repository, no matter where it is, whether it's a local Git repo, whether it's one that's hosted on Visual Studio Team Services, GitHub, Bitbucket, any type of Git repo is possible. And the nice thing is it really has integrated diff tools inside of the tool. You can do conflict merging all inside of Visual Studio Code as well as you go. Note that if you do some things in the command line, so maybe you'll be combining Git on the command line with Visual Studio Code, that works as well. So it will just pick up whatever you do from the command line and just make sure that the status reflects your current Git status that you've done through the command line. So there's nothing specific you need to do for Visual Studio Code. If you want to work with a command line, you can. If you do it inside of Visual Studio Code, you can do as well. So there shouldn't be no impact for you as a developer. So let's look at how that works. So I already talked about the version control view here. So let's click on this one here. So the first thing you see here, if you have a folder which is not under source control, you can, inside of Visual Studio Code, just do an initialize of your Git repository. You can just click the button. This will basically just do a Git init on your folder. So we can look here at the output if you want to see the output of our Git commands. And basically what you see here, now that we've initialized our Git repository, is that we can see all of the changes that are currently available as we make modifications, because every single file we added is basically a new change. It's basically a file that was not tracked yet, which we just added. They all appear here, and you can see an indicator here of the number of items that were taken into account. Note that if you have a git ignore file, which we have here, so we're ignoring node modules, the SAS cache, and some public components here, that will be taken into account as well. So that's why we only see 24 files here, and not all of the node modules, of course, which we don't want to check into our source code repository. So what we can do here is we can mark and stage every single file. So we can do this one here, or you can do it on an individual basis. So here we're staging every single file, but let's say we don't want to include our latest utilities here. Now let's remove this one here. So we have one untracked file which we're still working on. The rest we think we can safely stage and then commit. So we can provide our commit message here. So this is going to be our initial commit, and then we can just commit all staged changes. So just click the check mark here, which is basically just a git commit statement here. So you can look at the the git output. We should have it here. Sorry. So we can see that we still have one file, which is one change that we still have. This is basically the utilities file that we didn't stage and commit into our source code repository. Now this is all just the basics. So staging changes, committing changes. Now how does it work? What additional value do you get out of Visual Studio Code when working with version control? So one of the nice things I find is that you will get what we call gutter indicators while working with your file. So let's say you want to change a line of code here. So let's say we want to change this one dev to let's say dev instead of development. Let me take a sip of water. What you see here is, if I look here, zoom in a bit, you'll see this blue indicator, a color indicator, marking that blue indicates that you have modified this line. If you want to, let's say, remove a line, you'll also see like a red triangle here. Note that you'll also see here that additional file is being marked as a change for source control. And if you start adding new lines, you'll see basically the green indicator. So you can quickly see where lines were removed, what lines were edited, and what lines you're basically adding inside of your specific source code file. So this is nice to have a quick view of the changes that have happened, and you can see the changes here also in the scroll bar. So if you look at the scroll bar, you'll see these blue indicators here. Those are basically lines that were touched inside of your source code file. So you can quickly, if you have a large code file, quickly go and navigate to the pieces where you made modifications, and you can see them here very rapidly. Of course, maybe you want to do a side-by-side comparison of the things that were changed. So let's say we want to add invoke our, we want to add our, oops, not here. So we did our var utils equals our require, and that would be something like this, our utils.js, and we're doing utils.array. Need to put the JS here, and just do our utils.area. Not working here. Well, anyway, just adding it here. My file is being saved. What I can do to have a side-by-side comparison is I can just go here and do a switch to the changes view. If we go to our changes, what will happen here in our change, if we select a file, so for example here our app.js, we can see the lines that were modified. So this is the initial version, the changes on our working tree, and this is our currently modified file. So we've changed the development to dev on these two lines. We've removed one line here, added some blank lines, and added here var utils. And again, we can see here the modifications in the scroll bar as well. So the scroll bar indicates where the changes have happened. In our utils.js, we can see that it's basically just a new file. There was no existing version before. But if you just select one, you'll see before and after. Okay. Note that you can also switch to an inline view if you prefer that one. You can see before and after. Here, all inline in the same file. Or do just okay. So that's how we can make modifications under version control. So these again are kind of the basics. Viewing differences, checking in code, checking in changes. Here we've done, as you may have seen here, I can stage a given line here. So let's say I want to stage this specific modification. I can do so as well. So I can create patches as well. So in our app.js, we'll basically have only those two changes, and there will be additional changes here which are not currently being tracked. Okay. So you don't have to commit all of the changes. You can do patches as well on individual files. So this is all of the changes we make, the basic stuff. What if we want to do branching? Because we have support for branching as well. For that we go to the command palette, So we can go to F1, and then we could say git branch. So we can give it a valid branch name. So we want to create a new branch. Let's say feature 1. So we create a feature branch, just enter. And what we'll notice is we now have our feature branch. And then we can go and check out a specific, we've created just a branch, and we can now check out that specific branch by just clicking here on that specific feature here. We could say we want to go to and check out the master branch, or I want to switch back to my feature branch here as well. So if I want to go to my feature branch, and let's say we want to stage everything here, just made some changes. Let's commit this one in our feature branch. If we switch to our master branch, we should see that our utilities file is not yet in there, versus if we switch back to our feature branch, the utils.js file is in there, and also the changes we made to app.js will be in our feature branch. So you can quickly work with branches as well inside of Visual Studio Code. Okay. So that's kind of the version control experience. Now, going a step further is very often, as mentioned, you'll be using task runners such as Gulp or Grunt inside of your web development. Specifically, you typically use them for whether it's if you're using TypeScript for transpiling, TypeScript to JavaScript, or for going from Sass or less to CSS, to have all of the transpiling happening there, or maybe for cleaning up files, copying files across your different tree structure inside of your folder. And what happens is we basically have auto-detecting of all of those Grunt and Gulp and also Jake tasks are automatically picked up by Visual Studio Code, and you can execute them straight from within Visual Studio Code. So you don't have to switch back and forth across your command line and your editing experience. You can do it all inside of Visual Studio Code if you'd want to. So we'll be picking all those tasks up for you. Or you can as well create, as mentioned here, you can create your default build or test tasks as well inside of Visual Studio Code. So you'll have a keyboard shortcut for building your code, which is Control-Shift-B. Well, you can link that to, for example, a Gulp task, and we'll do that in just a minute. So that automatically you don't have to do explicitly, you can just do Control-Shift-B, and it will, for example, do the transpiling of our less code to CSS. And in addition to that, what we can do as well with the task runners is we can basically also add what we call problem matchers. So if your, let's say, less transpiler raises errors, we can pick them up and expose them inside of Visual Studio Code. And again, we'll look at how to do this. So switching back to our demo, what you'll see here is that I have a less file here, style.less. Has here a variable in there, and we want to have our CSS generated out of this less file. Yeah, we can do so using Gulp. So I have already specified here a Gulp file. So let me put this one aside, the two files here. So here we'll see that in our Gulp file we have a task, which is the less task. We also have a watch task that allows us to execute our less tasks just on a continuous basis. And then there is develop that will basically run nodemon just to fire up our web application. Yeah. Okay. So we have basically three tasks that we defined on top of the default Gulp task. Now, how do you run these tasks and these Gulp tasks or Grunt or Jake tasks inside of Visual Studio Code? We can just go to the commands palette again, so F1, and we could say task and say run task. Enter, and then we could say task, and you could see the progress bar appear here, and what will happen is VS Code is basically analyzing your code base, going through the gulp file and grunt files and jake files that you have. So you can here you can see it. So the first time it needs to analyze all this, so it takes a few seconds. So let's say we want to run our less task. Just select this one, just enter, and we should see, hopefully our output is it's starting now less. It's finished after 65 milliseconds, and you'll see the corresponding CSS file appear here. So if we put this one here on that side, we can see our less file and our CSS file, a corresponding one. Maybe nice to see here is that we have the color indicators. So if you say you don't know all the hex codes, you can immediately see if this is, let's say, AA, this is more greenish. If it's 00, it's more green. Or you could use something like this, do yellow. You get a visual marker here, what the color is meant. For the symbols, it's quite easy. If you're using these hex values, it may be more difficult. Yeah. So running a task, so we want to make the actual thing green. Just do task, run task. We do less, and we'll see that task will run, and we should see here the green value on the right hand side. So that's how you manually launch these gulp or grunt tasks. So it's quite easy. So we can take it one step further and mark these as default build tasks. So as we build our code, we want to transpile our less code into CSS. So how do we do this? Specifying these build tasks. What we can do is we can go to F1 again, to our command palette, and say task, and we can say specify the first one here, configure our task runner. So VS Code comes with a task runner to execute tasks. So there's a template of what you want to do. So in this specific case, we want to have a task runner that executes a gulp task. So let's take this one here. There we go. Let's close this one here. So what we can do now is, so we have our task.json file that has been created, which is the configuration for our task runner. So we can add a task now. So let's say we want to add a task of task name. Let's say our task name is less. Is it a build command? Yes, it is. And this will tie it to our Control-Shift-B syntax. And what we can do as well is we want to show the output in silent manner. Only if there's errors, just show it. And then finally, so this is just for tying it. What we want to add as well, I talked about this, so you can add arguments if you want to, but we don't need ones in here for less. We want to add a problem matcher. So problem matcher here is basically allowing us to map whatever comes out of the command line tool, out of this gulp task, and recognize basically the errors and warnings that come out of that command line tool. So whatever you see here in the output, here there's no errors, but if there were any errors or warnings, we want to pick them up and expose them inside of Visual Studio Code. And this is done using what we call a problem matcher. So in this specific case, we want to pick them up for a less compile. You can add multiple ones. So let's say we want to add also, let's say TSC, so for the TypeScript compiling, and maybe also for JSHint. So we want to do some JavaScript linting as well. Okay, so this is our configuration of our task runner. That's basically all we need to do. Now, if we want to do our compilation or transpilation of our less into CSS, so let's just for the sake of the demo here, delete our CSS file. Yes, I'm just doing delete. Then to run the command, to run our build, we just do Shift Control B. You'll see here a little thing turning around. We should see here our output, and our less has executed with no errors, so there's nothing to report here. Now let's say we put explicitly deliberately put an error in here. Let's remove the add here. So this is basically now there's not a valid variable definition here. If we now do our build again, Shift Control B, what we should get is in our output on the command line, this is what you'd see on the command line. So you get these error. So there's an error in plugin God bless, and there's an error message and some details in here. You could see it inline already here that there is an error. And on top of that, what you'll get here is an indicator that there's any errors or warnings. So we can click on here, and you'll see that there's basically 2 errors. So we expected here some different value, and then it says the variable link color is undefined. If you click on them, it will navigate to that specific line where the error is. So we'll have this one here. So as we fix this and make this again a variable, and then run our build again, so Shift Control B. We'll notice that it has finished our transpilation of less into CSS, and there's no more errors. So clicking on this one here says no errors or warnings. So this makes it really rapid to use your existing tasks, to get also the output from what you typically would have in your command in the command line. Just pick it up and have it all integrated in your development environment here. So all while still having that fast experience. So this is what we try to do, is give you this efficient environment, efficient experience, where you have all the information available to you if you want it. If you don't want to use it, well, you don't have to. So you can still combine command lines with working and editing in Visual Studio Code. Okay, so we're not really imposing anything on you. So that's how we kind of work a brief introduction to these task runners. Now the final component or process I want to take you through is basically the debugging experience. So Visual Studio Code comes natively with built-in support for Node.js. So automatically you get straight out of the box, you get a Node.js debugging experience, and you can add additional support for additional languages through extensions that you'll find in the Visual Studio Marketplace. And so there's extensions for PHP or for Ruby or even C# code debugging, and also if you want to add, for example, client-side JavaScript debugging. So if you're used to using the Chrome debugger tools, well, you can tie Visual Studio Code to the Chrome debugger tools through an extension, so that you can step through your code in Visual Studio Code while it's linked to your Chrome browser. We have the same thing. We have also an extension now for Firefox, or also Edge. And in our debugging experience, so we can, of course, set breakpoints. We can look at the call stack. We can look at specific variables. You can hover over variables inside of your code base and see what their values are. You get a debugging console, all integrated in your development code writing environment. Okay, so let's see how that works. So for debugging, so in this specific case, we have a node. Let's open this one. Oh, sorry. Open this one here, and let's open our app.js file. There we go. And let's say we want to. Let's remove this line here. This is just some temporary code. Let's say we want to add a breakpoint. How do we add a breakpoint? So either we can go to our command palette, so F1, and add and toggle a breakpoint, or you could use F9, or you could just click in here in the gutter and just add a breakpoint on the lines that you want to have a breakpoint on, like this. You'll see if we go to our debugging view, you'll already see the breakpoints here as well. So you can add breakpoints here by just pressing the plus button to add kind of dynamic breakpoints as well. So in this specific case, we're just setting a breakpoint on this specific line here, on line 13 and 19. So as our Express application is going to start, we want to have it break into the specific method, or on this specific line here. Now, one thing we need to do to configure our debugging environment is, well, Visual Studio Code does not know what your entry point is for debugging your Node.js code. In this specific case, it's our entry point is sitting here in our bin www entry point. This is where our application actually starts, where we basically start our server on port 3000. So this is going to be our starting point, our entry point for the application. So we need to configure the debugger. And this is done through by switching to the debugging view, just by clicking this configure icon here. And this will basically create what we call a launch.json file, and this a launch configuration file. So in this specific case, as I've already installed multiple debuggers, you'll see multiple ones. By default, you wouldn't see all of them. You'd see Node.js and the Visual Studio Code extension development. So if you're building extensions. So let's have Node.js in our case. So what you see here is the launch.json file that was created for you, and this contains the configuration of the debugger for your specific project here. So this configuration file so we'll have multiple configurations. So we have just a launch configuration, which will launch which specific program. So it's going to launch bin.www, kind of the default Node.js entry point. You can give it the current working directory. We can launch before launching the debugger. We could do a task that we want to execute before it. Let's say we want to transpile our less code to CSS, set some variables, etc., etc. We want to have source mapping, yes or no, or we can also attach to an existing node session. So we have here a configuration for launching the app, or we can attach to an existing already running node application. Okay, so here you could see here the port number. Note that you'll see here address as well. So we can also do remote debugging from inside of Visual Studio Code. Just specify here the IP address or host name of the server on which your node is running, and it will attach to that one. Okay. So in this specific case, we don't need to change anything specifically. So what we'll do to start our application, start debugging, we can press this little start debugging icon, so the green triangle, or we can just press F5. So let's use click on the triangle, and it will start on application. So you see the debug console, which is interactive. So you could say 1 + 1 = 2. So it's just a standard debugging console where you can do interactive commands, and you'll see that we immediately hit our breakpoint here on line 13. So we've hit our breakpoint, and here on the left hand side in our debugging view, you can see all of the local variables. So our directory name is sitting here, our app, and you can have our express, and you can dive into, if there's more complex objects, you can expand them as they are sitting here. So you can, as you can see here, we can also see our call stack of where we are right now. You can see the different modules. So right now we're in app.js. If we go here, where are we coming from? Well, we were invoked by this one here, and then as we step back, we can see where exactly we were being hit in our code. Okay, so we're in our app.js code. We can see our breakpoints, and then we can step through our code by using these buttons here, or using the F10, 11 keyboard shortcuts. So step over this one, and we step through our code. We'll see that development here, env development, and we can see we can hover over variables as well. So our node environment here, env is set to development. Directory name is the specific value, so you can hover over them as you go. The app object, you'll see that we have, and we can expand them as we just hover over them. So really a rich debugging experience all inside Visual Studio Code. So we can just continue and run our application. So our application now is running, and we should have localhost 3000 show welcome to Express. So very standard Express application available to you. So we can just stop it here, and you can see how do we switch between the different configurations. So we have our launch.json, so we had our launch and we have our attach. Just by clicking here, attach, we can, instead of launching the application, we'll attach to an existing Node.js application. Okay, so this is how you do debugging. So just a quick show of how do you get these extensions. Let's say you want to have the Chrome debugger experience or the Firefox debugging experience. What you can do is just in the command palette, just to F1, we can say extensions, install extension, and then you'll get the list of extensions. We could say Firefox, to search through the whole list, and then you'll see we have the debugger for Firefox. Just click this one. I already have it installed, so you can uninstall it, or I can install the Firefox remote debug just by clicking this one here, or just clicking this. What will happen is it will install. So it was successfully installed. Just restart Visual Studio Code to enable it, and that's basically it. That's how you can get all these extensions. Where can you find them on the web? Basically, you can just go to marketplace.visualstudio.com, and you'll find the extensions for VSTS, but also for Visual Studio Code. Click on this one here. There you'll see all of the different extensions, so the recent ones. So if you're looking for debuggers, just click debuggers, and you'll see like PHP or React Native, Ruby, and so on and so on. So a whole range of extensions that are here for you just to install, and you can see whether they're free or preview or paying extensions. With that, I'm returning to the presentation here. So Visual Studio Marketplace, all types of extensions, whether it's going from themes, debuggers, adding new language support, and so on and so on. So to close off this session, a number of resources. So where do you get Visual Studio Code? Just go to code.visualstudio.com, the link to the marketplace, and also the link to the GitHub repo where you can look at the source code of VS Code. With that, I want to invite you to join another one of our JavaScript webinars. That will be in 2 weeks, when we'll be back to talk about how to create extensions for Visual Studio Code. As mentioned, if you have any questions, feel free to reach out to us on Twitter. And with that, I want to thank you and hope to see you in one of our upcoming webinars.